All right, everybody. You should see a joinpd.com code in front of your face. So I'm going to go ahead and close this and move to chat. The old join pd. Nope, that's not the right button. No, it's not the right button. That's the right button. Joinpd.com HZGCST. All right. For this one, you need to find the value of x and y given that this is an isosceles triangle. So you should have from your notes on Thursdays, last Thursday's class, the isosceles triangle theorem. You're going to have to use that to solve this for x. And then once you have x, you will have to use the triangle angle sum theorem to solve this for y. I'm going to give you 3 minutes to try this, and then we'll go over. I'm going to try to give you hints every minute. I failed that during second hour, but I'm going to try better to do that during this hour. Okay. All right, while you do that, I'm going to go away from this shared screen for a bit to help out, to give some instructions to my AP Calc students. So again, that's the joinpd.com code that you'll need. All right, so patience, what do I need to do? I need to do this. Okay. So, all right, patience, you should have, I think you should have it under your assessments tab, just like the previous one. Assessments. Unit 1, quiz 2. All right. There's 9 questions. It's due at the end of the day. The only thing that's weird about this one compared to previous quiz that you did is once you hit question 5, this is the pre-response question. And you can answer this by just typing. But also, if you do your work on paper, you can enter an image of your work. So if you do your work on paper and then you email that image to yourself or whatever, and then download it, you can attach it and it will just copy and paste then your picture into this field. Okay? I was gonna say, I don't know if this tool tells you about that. No, I think that's what you have to do. Okay, so you can either type it in here or add the picture into here. Okay, so let me give you hints now for this. All right, so here is your hints to get started with this problem. You should have in your notes from Friday the following theorem. If you do not, here is, I think, one of your last chances to write it down. The isosceles triangle theorem states that the base angles of an isosceles triangle are congruent. What that means is they have the same measure. So since this is an isosceles triangle, these two angles down here are my base angles. Remember, the base angles are the angles that are not between the congruent sides. So y is between these two congruent sides, so it is not a base angle. The base angles are the other two. So the isosceles triangle theorem tells us that those two angles are congruent. They have the same shape and size. So I can write that 3x minus 2 must equal x plus 38. I then need to solve this for x. Get all of my x's on one side, all the numbers on the other. Once you have x, you need to plug it back in to these angles to, okay, that was kind of sloppy. Let's try that again. You need to plug it back in to these angles or into these equations to get what the actual angles are. And then once you have what the actual angles are, you can find y, because we know y plus our base angles have to add up to a certain number. The three angles of a triangle have to add up to a certain number. And if I know what these two are, then I know what y has to be. Okay, that's my hint. I'm going to go ahead and restart this timer. And let's see if we can get some right answers. You don't need to type the right answers in Pear Deck. You can just send them to me in chat, like a few people have done already. And I will go ahead and confirm now the answers to those people who did it in chat. Do, 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 do. Yes. I might be missing stuff in chat. My chat is blowing up. I'm the most popular kid in school. Okay, let me double check. I got that response. Okay. Okay. All right, it looks like we're doing pretty good, actually. All right, let's go over this in case you're stuck. But I have to say, I'm really impressed compared to first hour or second hour. Second hour, they were like lost in the woods. All right, so again, the isosceles triangle theorem tells us that the base angles are congruent, which means I can write 3x minus 2 equals x plus 38. If I want to solve this for x, I need to get all my x's on one side, numbers on the other side. For me, that means I'm going to subtract the x's, and I always subtract the smaller x. So I'm going to subtract 1x from both sides to get 2x minus 2 is equal to 38. I have 2 more steps to get x by itself. I need to get rid of the times 2 and the minus 2. To get rid of the minus 2, I would plus 2. To get x is 40, or sorry, to get 2x is 40. To get rid of the times 2, I would divide. 40 divided by 2 is 20. All right, remember that 20 is not your angle, 20 is x. To find the angle, I would do 20 plus 38, which is 58 degrees. Similarly, 3 times 20 is 60, minus 2 is 58 degrees, which makes sense, right? They were supposed to be equal. So once I have x is 20, I plug it back in to find the angle. Both of these base angles are 58 degrees. All right, to find y, I know 2 out of 3 of my angles. And I know that all 3 angles are supposed to add up to 180, according to the triangle angle sum theorem. Again, that should be a theorem that's in your notes from last Thursday's class. The triangle angle theorem, angle sum theorem tells you that the 3 angles of a triangle add together to equal 180. So to solve this for y, I would combine like terms. 58 plus 58 is 116. Subtract 116 from both sides, and you get 64. Ba 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 ba. Cool. All right, cool. All right, so I think I said this for the afternoon class. I don't know if I said it for the morning one, but so we're not going to have a quiz today. We decided to push that back. We're going to have the quiz tomorrow instead, and today is going to be a review day. So I'm going to go over some more algebra proof examples, and then we will do homework number 9 and number 10, the geometry proof ones. Okay? And then the quiz will be tomorrow instead. The other big announcement, the other announcement, administrative thing, is Monday I will not be here. You will have a sub instead. For that class, I'm just going to have the sub show you a video lecture. I'm trying to see right now if I can find one online that I've liked. I haven't found a great one yet, so it might be me. The video lecture might be me lecturing at you, and then you'll have a homework assignment. And that lecture will continue to Wednesday. So if there's anything that you struggle with Monday, we will have another like review day on Wednesday to cover it. Kind of like how we did this week, where we had Monday lecture and now we're going to do some more examples. We'll do the same thing next week. I won't be there for Monday. All right, questions about any of that? Clear this and move on, or does anybody need more time to write? Okay, let's do it. All right, so here is the first example. I'm going to go over another algebra proof example. So how these algebra proofs work again, and this is the same thing you will see on the quiz tomorrow, is you will be given an algebraic equation, and then you are asked to use that to prove that your variable is equal to a number. So I'm given that 3x plus 2 times the quantity x minus 5 is equal to 15, and I want to prove that x is therefore 5. To do a proof, I use a 2-column structure where I will write true statements on the left and the reasons why those statements are true on the right next to them. The way you start every proof is always the very first thing that you know is true is what you are given in the proof or in the instructions. So I'm given that 3x plus 2 times the quantity x minus 5 is equal to 15. And the reason that I know that statement is true is because it was given to me. Every proof starts out like that. You will, if you start every quiz just copying the given and writing given next to it, you can do that for the quiz tomorrow. You can do that for the unit test that we have in 2 weeks. You can do that for the unit 3 quizzes, the unit 3 test, and you will do, that's just free points every time. Free points just given to you. All right, my goal is to prove that x equals 5. So I need to get x by itself on the left side of this equation and all of my numbers to the right side. There are many different ways you can do that. So my proof for this could look different than yours, and we could still have the right answer for both of us. What I would do next is simplify this. I don't like having parentheses in my problem. To get rid of those, I would take this 2 and I would distribute it through the parentheses. If I do that, what I would get is what? 2x minus 10. 2 times x is 2x. 2 times negative 5 is negative 10. And again, the reason I know that this is a valid step, right, that this is still true, is because of the distributive property. The distributive property tells me that I can take a term in front of a parentheses and multiply it through the parentheses. All right, and this next step is really where I think our proofs could diverge. If you added 10 in this next step, that would be perfectly okay. Again, I always like to simplify first. I just like to take messy things and make them nice and neat first and then start solving it. So I'm going to simplify this because I know 3x plus 2x can be combined together to be 5x. And again, I did that by combining like terms. And you'll notice that all these are in that reason bank. I gave you Monday. So I don't know. I think in the earlier class, these were left out of the slide, these two. So if that isn't in your reason bank, you might add those two. I think I fixed that for the afternoon and my second hour classes. But I think the very first third hour class, for some reason, they didn't copy over into the PowerPoint. All right. Next step, I've got two more things I need to do to get x by itself. I need to get rid of this 5 that's being multiplied by x, and I need to get rid of this minus 10. To get rid of the minus 10, I would do the addition property of equality, and I would add 10 to both sides. On the left, that leaves me with just 5x. On the right, 15 plus 10 is 25. Last thing I would do to get x by itself and get rid of this multiplying by 5 is to use the division property of equality. And I would divide 5 by both sides to get me x equals 5. So again, I can't stress this enough. Even if you are absolutely lost right now, which hopefully you aren't absolutely lost, but even if you are, there are free points sitting on this problem for you just to get by copying and pasting. The first statement is always going to be what you're given. And the first reason will always be because it was given to you. The first thing I know is true is what is told to me in the instructions. And the reason why I know it's true is because it was given. And then the last thing that you will always write is what you're trying to prove. So 3 of these blanks are already filled in from you in just the statement's instructions. You just copy and paste them. And then you just have to think and use your brain to say, how do I get from point A to point B? How do I get from this equation to a single x on one side and a number on another? And that's really where, you know, your geometry class can focus on. Okay, hold on. I will, if you can't see, here's what it is. Number 5 is x equals 5 because of the division property of equality by dividing by 5. That's the last line. I think that might be a zoom issue. You might have to zoom out, maybe. All right, questions about this? All right, I'm going to clear this and move on then, unless someone says they need more time to write. Okay. All right, let's do one more. So for this one, we are given 4a minus 10 is equal to 6a minus 4. I need to prove that a is equal to negative 3. All right, what's our very first statement? What do we know is true? What we are given in the instructions. 4a minus 10 is equal to 6a minus 4. Why do we know that's true? What's our very first reason always going to be?
It was given to us.
Because it was given to us. I know what you're thinking. If all this stuff is just given to us, should we feel bad that we didn't bring a return gift? And yes, you should. Yes. I mean, can you, for just once, right? Couldn't you just make a small thing? You don't have to spend money on it. Just make a gift to give to your homework, right? All this homework is giving you practice, but have we ever really stopped and think, how does the homework feel about all this? You know? Chocolate is always a great gift. Homework likes chocolate. People like chocolate. Okay. This is really going to diverge. I know my last line is going to be a equals -3. Okay? To get there, you could do multiple things. I tell you what I'm going to do. Okay? And this is going to shock you. So if you are not seated, please seat yourself, because what I'm going to say next will shock you. It will rock your world. I'm going to subtract the 6x. What? No, Mr. Lake, you always subtract the smaller number. But no, not this time. Not today. Okay? Every once in our life, we get to these critical moments where we get to choose, and those choices impact the trajectory for the rest of your life. And this is one where I am choosing to subtract the larger number. Why, you say? Why? Because I want my A to be on the left. That's it. The A is supposed to end up on the left side of the equation, so I'm going to get rid of the A on the right side. If you do not do that, that is okay. All right, if I subtract 6A from both sides, 4A minus 6A is -2A. Minus 10 is equal to -4. I know. I know. If you subtracted the 4A instead, that would be okay, but then your A is going to be on the right, and you will have to do a 5th line. If you subtract the 6A instead so that your A is on the left, you can do this proof in 4 lines.
Like, you just rewrite it and you just know.
Okay, here, okay. Technically, this is what you would have to do. Well, let me finish this, and then I will show what the other proof looks like. You are right. But it does take a 5th line to do it properly. All right, I got 2 more steps. I need to get rid of the -2 times, and I need to get rid of the -10. Opposite of -10 is add. Did I goof? Yes, I did. That's not right. That's not right. That's wrong. -4 plus 10 is -6. Come on, or is +6. Jeez. 10 minus 4 is 6. Or -4 plus 10 is 6. All right, last line. If we divide by -2, we'll have A by itself. Okay, again, if the last line cut off for you, I'll rewrite that. The last line is A equals -3. And the reason why that's true is the division property of equality where we divided by -2. All right, does anybody need more time to write that, or can I clear that and show what the alternate proof would look like? No? Okay, here's what the alternate proof would look like. I did not need to erase as much as I'm erasing. Okay, here's what you would do. Okay, here's what you would do. 4A.
Wait, what are you writing down now?
I'm writing down an acceptable answer besides the one I've already done. This is another way you could do this. Yep. All right, and then what would you do? You would add 4. And then we would divide by 2. And then here's what we would do. We would write this. because of the blank property. And this is what I was talking about Monday. Does anyone remember what is the property that tells us if -3 is equal to A, that means A equals -3. What's that property?
Symmetric.
The symmetric property. That's why. And I know what you're saying, Mr. Lake, isn't that just super obvious? Do we really have to write the symmetric property? Technically, yes, because the proof did not ask us to prove that -3 was equal to A. It asked us to prove that A was equal to -3. Now, if you actually did this on a test and left it like that, would I ding you for not doing this last line? No. If you take college geometry, though, yes, they will ding you for that. So if you want to be a math major, yes, they will ding that for you for that. If you want to be a programmer, yes, they will ding you for that. Because in programming, that's how bugs get created. When you say something's close enough, when it's really not. You have to be super precise when you're doing programming. And it actually does follow a lot of this logical structure we use is the exact same logical structure that's used in a lot of programming formats. Isn't that cool?
Mr. Lake, I have a question.
But
Did you just rewrite like what we had earlier?
that's right, with a different style of proof. This is, you'll notice that we get to the same answer, but this takes 5 lines, right? And it's a different way of doing the proof. So when you take the quiz, oh shoot, actually I'm lying. I'm lying to you because, all right, can I clear this? All right, here's why I'm lying to you. When you take, whenever you do a proof, there is almost always more than one way to do it. Almost always. When you take, I closed out of the quiz because I'm a numbskull. So I was going to say that when you take the quiz, there could be more than one correct answer, but actually I don't think there is. Because when you take the quiz, all you have to do is fill in the reasons. I have all those statements written for you. So you just have to fill in the reasons. So everyone's answer should be the same for the quiz. Okay, let's see if you have been following along and you understand the knowledge that Mr. Lake is just giving you. Try this one. And again, for this one, everyone in this class could possibly have a slightly different answer from each other, and we could all have full credit. They could all be correct. And, oh, and again, you don't need to write anything for Pear Deck for this because, I mean, there's no way for this to fit into Pear Deck. So, sorry. I'm just going to trust you. I'm going to trust that you're doing it this time. I will show my work in 4 minutes. You do not need to send me anything in chat or Pear Deck. You can. You can send it to me in chat, but you don't have to. All right, here's my proof. Again, if you didn't follow this exactly, you could still have the right answer. This is what everyone should have. Everyone should have that the first statement is 10y plus 8 minus 3y is equal to negative 6. And the reason why we know that's true is because it was given. Everyone should have that. And everyone should have that their last line is y equals negative 2. Now, what happens in the middle can kind of change. Some of you may have subtracted 8 first. Some of you may have combined like terms. I'm going to combine like terms first. 10 minus 3y is 7y. Again, how I got that was combining like terms. Like terms. Step 3 for me then would be now I would subtract 8. And then that would give me negative 14. And then to get rid of this 7, so I have just y, I would use the division property of equality, where I would divide both sides by 7. To get me negative 14 divided by 7 is negative 2. Alrighty, that's algebra proofs. Do we feel okay about that? Or do you want to see one more? Are you ready to move on, or you want to do another?
Hold on.
Move on. Alrighty, let's move it along. Okay, so the last thing that we're going to do today is I'm going to do some homework problems for you. All right, so I had a lot of questions on these through email. Here's the first thing I will tell you. When you are looking at the instructions for this assignment, it says you need to watch the video first and then complete this. I did not lecture on this in person. That lecture is in this 18-minute video. All right, so you should watch this first before you attempt to do these problems. Now, these problems are tough, so even after you watch that, you might be a little confused, which is why we're going to go over them together. All right, number 9. given that X is congruent to Y, we have to fill in these blanks to prove that line L here is parallel to line M. What is my first statement going to be? What is given?
X equals Y.
Yeah, X is congruent to Y. So how I'm going to write that is, remember the symbol for congruent is this. I mean, you could just copy and paste it word for word, but the reason why I have this blank so small is because I expected you to write it like this. Okay.
If we didn't add the congruent sign but just had it that it equaled each other, is that fine?
No. No. It is a great question. I'm really glad you asked about that, Hannah. That everyone does that every year, and there is a difference. Right now, the difference seems totally minuscule, but that difference becomes a big deal in chapter 3. That's why I'm going to enforce it now. Our second line should be, because they are congruent, that means that they're equal. So your first line should have the equal sign with the tilde for congruent, and then the second line should be your strictly equal to one. Again, you might say, Mr. Lake, there's no reason why this has to be 2 sentences. I think I could jump straight to number 2 here. And again, right now, that might seem absolutely true. But as we move into Unit 3, and especially when we move into Unit 4, when you start mixing up what congruence and equal are, it'll mess you up for those proofs really badly. So if we can force that separation now and stick to it, it'll make Unit 3 easier. All right, so I have 2 congruent angles, which means that they have the same measure. That means they equal. Line 3 tells me that angle X and angle Y are corresponding angles. And I'm told that's going to become the definition of blank.
Definition of corresponding, I think.
That's right. It's the definition of
Oh, really?
corresponding.
Oh, I'm smart.
And you can put corresponding angles. You don't really have to put the angles term in there. But again, proofs are tough. But once you start doing a few of them, there's a lot of stuff in proofs that make them easier. Sometimes the difficulty comes in because you will want to make it harder than it is. The reason why I know X and Y are corresponding is because in our notes, that is the definition of what corresponding is. Angles in the same position, right? X and Y are both in the bottom right. They're in the same position. So according to our definition, they are corresponding. All right. The last thing, again, I'm telling you, proofs are tough, but if you use the structure to help you out, they are not. I could know nothing about what has happened in the last 10 minutes of Mr. Lake talking, and I could still fill in this last blank. What has to be the last line of every proof? What you are trying to prove. It has to be the last line. That's the goal, is to prove that L is parallel to M. So all of this could be gibberish to me, but I know the last line has to be L is parallel to M, because that's what we were trying to prove. All right, let's see why we can write this here. It says the reason is because parallel lines have the same slope according to the parallel postulate. So again, what this proof is telling us is if I am given that these 2 angles are congruent, that means that they have the same measure. And since they are corresponding angles, they are in the same position. That means these lines intersect this transversal at the same angle, which can only happen if they have the same slope according to the parallel postulate. So therefore, the lines are parallel. Right? Remember, and that's what our corresponding angles theorem says, right? If 2 lines have congruent corresponding angles, then they are parallel, and vice versa. If they're parallel, then the corresponding angles have to be congruent. All right, let's look at number 10. All right, I'm going to talk through number 10, but I'm not going to write this because I want you to at least have to spend a little exertion on this homework. What is the first line going to be? Again, what are we given?
L equals M.
No, not equals, but parallel, right?
So congruent.
Actually, use this formatting, the two vertical lines. Again, okay, so this is another thing. You could just copy and, so when you're doing this test, you could just copy and paste this word for word. Word for word, that can go right here. As you get more fluent with the notation, it'll save you time if you just use the notation. So if I use L, two vertical lines, remember that's the notation for parallel. So L parallel M. All right, I'm supposed to, given that, fill in the blanks to prove that angle X and Y, the alternate interior angles, are congruent. All right, my next line says that X is congruent to Z because of the what angles theorem. What type of angles are X and Z? Are they corresponding, alternate interior, alternate exterior, or consecutive?
Corresponding.
Corresponding. So corresponding goes right here. The corresponding angles theorem tells us that if our lines are parallel, then the corresponding angles are congruent. Three tells us that angle Z is congruent to another angle because of the vertical angles theorem. So if I look at this picture, what angle is vertical with angle Z? There's only one other angle left, right? That goes right here. All right, last line tells us that that means angle X is congruent to angle Y because of the what property? Okay, so if you remember, we had a property in your notes that said if A is equal to B and B is equal to C, then that implies that A is equal to C, right? The same thing is true of congruence. If A is congruent to B and B is congruent to C, then A is congruent to C because of what property? Which one is that? Reflexive, symmetric, or transitive?
Transit?
Transitive. That's right. So that's the transitive property. X is congruent to Z. Z is congruent to Y. That means X and Y are congruent because of the transitive property. Isn't that fun? All right. 9 and 10 are not on the quiz tomorrow. There are no geometry proofs on the quiz tomorrow. It's just algebra proofs and, well, let me show you. So you've got a triangle angle sum problem. You've got an exterior angle problem. You've got an isosceles triangle problem. You've got an algebra proof. That this is a review question. You've got one of those questions that's was from last week's quiz about angles at two opposite intersections. So you have to do like, are they corresponding, alternate interior, all that stuff, and then an extra credit question. All right, it's going to be open notes. It will be in person this time for most of you. So do be ready for that. I am going to have you do it on your own sheet of paper. I don't want to pass out a bunch of stuff and then get back a bunch of stuff. That seems like too much contact points for me. I would rather you just pull it up on your Chromebook and then use your own sheet of paper or type it in, just like you would do like if you were taking it from home. So if you want to do it on paper, you should bring paper tomorrow. All right, any other questions for me? Okay, so as a reminder, quiz tomorrow, next Monday. I'm not going to be here. You'll have a video lecture and assignment to do. We will go over that assignment, some of that material for Wednesday's class next week. And then if you have any missing homework, make sure you try to get that in as soon as you can. Because doing homework assignments 2.1 through 2.4, as you could tell, I just showed you, that's what the quiz is about. So if you can do those, then I think you'll get a good grade in the quiz. If you haven't done them yet, trying to do those problems for the first time on a quiz is how you get yucky grades. All right. Well, if there's no more questions, oh, last announcement I should make. Reminder, next hour is 4th hour. No seminar today. You go to 4th hour next. Okay, no seminar today.
Why isn't there seminar today?
There's no seminars on Wednesday anymore. It's the new schedule. Okay, it's gonna be kind of reversed, but you just go 1, 2, 3, 4. Everyone has the same lunch, 5, 6, 7. So after this class, you go to 4th hour. After 4th hour, you go to lunch. Then 5th hour. Everybody does that.
When does 5th hour start?
12:12. And hopefully your 4th hour teacher will remind you of that too. All right, well, last call for questions, or I'm going to end this a little early today. Okay. Have a good day, everybody. I'll see you
I got
tomorrow.
a question.
Oh, what's that?
Since we don't got seminar, do we get out of school early or what?
No, so it's just they extended each class. So
Oh,
yeah, each class is, I believe, like 3 minutes longer. 4. Seminar was so short anyway. Yeah. All right. Bye, everybody.